Now, this is our sixth lesson on circle properties. And our focus for this lesson now is going to be on what we call tangent, chord, and then the angle properties that govern what we call tangents. When you look at my screen, the pictures you are seeing might be a bit familiar to you. Some of you, I know you have bicycles at home, you have those gear wheels, but yeah, if you have not observed it well, the design of what we have here is mathematical in nature, and they always apply mathematics when they are designing them. So what we are going to look at today is going to be an application of this design of systems. When we come to applications of what we are going to talk about in this particular lesson, we shall relate the application to some of the things that we use at home that we have not been maybe knowing that this is where the mathematics is. So when you look at what I have on the screen, you notice two things. One, Timothy, is it a question? Timothy? Okay. When you look at what we have at the screen, you are noticing that I have a bicycle. There is a bicycle on my screen. Now, when you look at that bicycle, there is one thing. You are noticing that I have there are two things. This is the ground and this is our tire when it is touching the ground. Now, when the tire touches the ground, this is a mathematics concept. When you notice that our ground is straight, so it is a line. The tire is a circle. So we are going to look for this particular part we are going to look at. We are going to look at which kind of relation exists when the circle meets a straight line or meets a line or meets the ground. And this particular thing is what we call tangency. So whenever you have a circle and the circle is meeting a line or is touching a line at only one point, that point where the circle touches is what we call tangents, or what we call the point of tangency. So in our today's lesson, we are going to look at that. But also, I want you to observe, when you look at this is our tire, and our tire is in a circular form. But when you look at it very well, still also, when they are putting back those bicycle spokes inside there, please, they don't just put them anyhow. Always, there is a mathematics shape we form. I want you to observe that tire. And tell me, those who attended the first lesson, which shape or which thing are you noticing in that tire? There is something we talked. Which kind of figure or which name can you identify from the way those bicycles? Okay, I'm seeing Emma. Yes, Emma?
For me,
Mm.
I am seeing that those spots are arranged in according to the triangle
Uh-huh.
shape.
The triangle shape. And which name did we give that triangle shape?
Hey, I'm sorry, I wasn't there in that class, but I can see this one at this time.
Oh, okay. Anyone who
Yeah.
remembers? Very good. Very good. Okay. Yeah, very good. So we called it a sector. So when you look at them very well, the way they are arranged, you can notice that we are going to be formed. There is some kind of sector when you look at them or when you observe. So those, when they are putting them inside there, they always put them in a form of a sector. So for this particular one, we are going to talk about a circle, we are going to talk about a line, and we shall be talking about a sector. And let me even tell you, whenever, for you to move well, that tire of the bicycle must be able to touch at only one point on the ground. Should it touch more than 2 points when it meets the ground, you can never be stable. That's why when you don't have air in your tire and when it is flat, movement is not possible. Like you can't move stably. So that's why because that tire is going to be touching more than 2 points on the ground. So you'll find that your tire is like this. So there is no stability. There is no tangency. So you cannot move very well. So that's why in the design, it is really very important. And when they are designing these things we use in architecture engineering, they will always consider what we call the tangency. So I want to bring it to your attention that when we talk about the tangent, whenever the tire's contact point with the ground, it represents that tangency. And for it to be stable on the ground, it must always touch one point. That's why whenever the air in the tire reduces, you cannot move steadily. You'll not be very stable on the ground. Okay, now also the spokes, the bicycle spokes, like we have said, they are going to be forming what we call a sector. And from the sector, we shall be able to obtain what we call a secant. And even here, you need to take note is that if someone doesn't arrange them very well in form of a secant, you'll not still be stable on the ground. You may even fall, but also chances are high that even your tire will get spoiled quickly. So that's why always you need to be very observant. But currently, when it comes, there is another way they have started designing using big seconds. Yeah, for some of the modern bicycles, they're using those big things. But also, I don't know whether people can notice what I have displayed on the anything you are noticing on my screen. Do you know any of those pictures? Okay, yes, Desire.
I notice the sun
Mm.
and how the earth is curved and the way it is able to save the sunshine, maybe due to the rotation.
Okay, perfect, good. Yes. Now, here, I want also to bring to your attention. And here, what I want to bring to your attention is what you call the way the sun reaches to us and the way we put solar panels. Those solar panels you may be having at your home, when they are orienting them, when they are placing them on the roof, on anywhere, always they must be tilted at a given angle. And the angle at which the angle at which they are tilted will determine how much sunshine or how like the amount of radiations it is going to receive for you to be able to receive light. When they are poorly placed, when they are poorly placed, you'll not be able to receive a lot of energy for you to be able to use it to see or to cook. That's why for someone to place for you those solar panels, they need to be experts such that they know that when we place it like this, but the way they place it, still it involves what we call a circle and what we call tangency. In other words, that what happens is that when we receive radiations from the sun, our sun, being that it is not a complete circle, what happens is that when these radiations hit us, they hit us at a given angle. For example, there are times when you feel, mainly in summer, when you feel it is very hot, extremely hot. What does it mean? It means that the angle at which the sun is hitting us, it is perpendicular. But whenever the angle at which the sun hits us is a small angle, less than, it means that now we shall have a lot. Whenever we call it at the angle of incidence, whenever the angle of incidence is very small, what it means that a lot of sunshine is able to reach us directly, and therefore it will lead to high energy absorption. So you will feel it very, very hot. Now, like in January, So here the angle, or we call the angle of incidence, is always very small. So when they are tilting, they must always aim at getting that particular angle. So when you are tilting that solar panel, let me say it is like this. Always you must look at where the sun comes from. And then you look at the direction. If this is my sun that is coming, always you know that the sun will hit you at a given angle. So when the radiations are coming from the sun, they will curve like this. Let me say like this. So the person placing the solar panel must be very observant, or must make the calculations to ensure that these radiations, when they're reaching this panel, like this, when you look at this, this is the curved path. This is like how the rays are going to move like this at a given angle. And now this point here, we have said that whenever a circle or any circular thing meets a line, it must, that's what we call the tangents. So for the person tilting the solar panels must always ensure that it is at angle of tangency, because at that angle of tangents, the angle of incidence is always very small, meaning that you can be able to receive maximum amount of energy from the sun. So those people who have solar panels at home and it is not really working well, one of the reasons it is the way your solar panel was placed. It was not tilted at a given angle. It was not tilted very well. Or or it can even be other internal things. But one of the reasons is that because at some of your times you may have a lot of sun, but when you look at the energy you are receiving, it is really very small. So it always, you must look at how they are tilted, because that way they are tilted, it always will determine how much energy they are going to receive. And that amount of energy will depend on the angle of incidence at which the sun hits that solar panel. And always that angle is always determined from the tangent point. But this one, I may not dig deep into it, but you can read about it in your free time. But what I wanted to just bring to your attention, that when the sun is moving, when it is hitting us, it always hits us at a given angle, and it forms something like a curve, those rays. So always we tilt it, we make sure that we tilt it such that we can have this angle as small as possible, such that our solar panel can receive the maximum amount of energy. And the smaller the angle, the more energy you will be able to receive. So that is what you call the solar energy panels. So that tangential part of it is going to be very applicable. Now, allow me to dig deep into what we are going to look at. Now, for this particular topic, we are going to look at the tangent properties. When we are looking, like I've told you, tangents, when you hear the word tangents, tangents means we are going to look at us having a circle, but that circle is touching a line. You have a circular figure. It may not necessarily be a circle, as long as it is something circular. As long, even if it is not circular. But here, since we are looking at circle properties, we shall be considering circular thing. So circular, so when we have a circle, as long as we have any line that touches that circle at only one point, this point at which it touches when a line meets the tangents, meets the circle, is what we call the point of tangents. However, but this line here is what we call the tangent. So a tangent is that line. Then the point on when the circle meets the line, that point is what we call the point of tangents. So whenever a tangent meets the circle, there are some properties that are always being displayed. And that's what we are going to look at in this particular topic. May I know through the chat whether we are on the same page, whether you have understood what we call tangent and tangents. Okay, okay. I'm seeing a question coming in from Mugisa. Yes? Okay, we can start writing. Yes, Mugisa? Okay. So let's write something. And please don't forget, a tangent doesn't pass through a circle. So when you are drawing it, it must just touch, but not going through. So it is just, so when you look at my diagram, when it is not so touching, for yours must touch at one point. So I want you to go on, and then you label on your diagram that this line is what you call the tangent to the circle. And then this point here that I've labeled green is what we call we call it the point of tangents. Okay, are we good to go? Largely done. Okay, okay. We can now start the first theorem. Now, our first theorem is that whenever a tangent, this is what we have called a tangent. Whenever this line meets a radius, they will always meet at 90 degrees. So the angle you have here will always be 90 degrees. Whenever a circle and any line, it doesn't need to be down. So please don't get it that always must be down. And this is my line. As long as this is the radius, the point from here up to here, where the radius meets the tangent, they will always meet at 90 degrees. That is the first theorem. So whenever you are dealing with these circles, you look at your circle. Take an example. You are going to be meeting maybe calculations whereby you have something like this. This is my center. And they will tell you, and maybe you have something like this. Okay, it has not come out, but as long the angle you always have here will be 90 degrees from between the radius and the tangent. So whenever they meet, they will be at 90 degrees. That is the first theorem. So take note of it. But always it is the radius, not any chord. So don't confuse that as long as it is a line. No, it must be radius, not a chord. So they must always meet at 90 degrees. Okay. Let me hope we're on the same page. And you can let me know whether we can. Patricia is saying yes. Emma is saying yes. Okay. Okay. It seems people are saying we are good to continue. Okay, that is the first theorem. Now we have the second theorem. Now the second theorem, it's the one that we are going to we need to understand also. Like we have said that a tangent is any line that touches the circle at one point. So when you look at my figure here, you can notice that allow me to label it. Oh, sorry. Okay, this is my point A. I'm going to call this point B, and I will call this point C. What do I need you to know? That the angle I have, we have said that when a radius meets this, the angle we shall have here is 90 degrees. Similarly, the angle we shall have at A is also going to be 90 degrees because the radius is meeting with the tangent. Now, but for this property, as long as the point or those two tangents are originating from any point outside the circle, the length of the line, this is what we call the external. External means something outside. Yeah, so the length of the external to this point will always be equal from A to C. So the length of the line AB will always be equal to AC. That is something you need to take note of. Similarly, the same thing will happen that the distance from the center to B, what we are calling your OB, is the same distance from O to A because you can notice that all those ones are radius. So from O to B is radius, and from O to A is also radius. So those two things are going to be equal. I don't know whether we are on the same page. Kindly let me know whether that is very okay as I answer Apollo. Yes, Apollo.
Master, good morning.
Good morning.
I was like asking, is it supposed to be AB or BC?
Which one? Oh,
This one.
okay. Now, this is SC, then this is BC. Okay, thank you.
So that AB is equal to AC.
Yeah, this is supposed to be BC. Sorry. B to C. Yeah, this line here must be equal to the line down. Okay, thank you. Yes, Fiona.
Good morning, sir.
Yes, morning.
Mine is just a question. I wanted to ask whether from point O to C can also be equal, like the line from BC or AC.
Okay. Now,
Mm.
Fiona, those ones can be special cases, but they are not equal. Reason being is like whenever you have a triangle, a right-angled triangle, you cannot have all sides equal for a right-angled triangle. If you cannot swell, B, O, and C is a right-angled triangle because you have a 90 already. So this line here cannot be equal.
Okay, thank you.
Okay. Emma?
Now, teacher,
Yes.
I wanted to ask like this tangent theorem too.
Hmm.
How can it be applied in our everyday life?
In our everyday life,
Yes.
okay. Uh, let me hope people. Emma, don't go off. I want
Yes,
to, I
I'm
want you
still
to,
here.
yeah, I want you to just tell me whether you can see some kind of relation here. Emma,
Mm.
you see some
Yes.
kind of relation with this?
Yes, I can see it. This one, the Z
Yeah,
one.
yeah, yeah. Even this one. So that
Mm.
that one, it is the application of this.
Yes.
Hope it is okay now.
Yes, it is okay.
Okay. Yeah. So here, what we are calling our external point, here, this is where, like, when they are designing those gears for bicycle and rest, this is where they will put that second gear. So they can place it here, something like that. Okay, so that's why when you look at when the chain is moving, you'll always notice that this part down for the chain, this part up will always be equal to the part down. So this distance here will always be equal to the distance that you have down, but it comes from this design. Okay, so I think I'd call this A, this was B, and this was C, and we had said that our BC is equal to AC, but also OB is equal to OA. Now, another thing I want to bring to your attention is that also the angles we have at this point, If this angle is maybe, let me say theta, it will be equal to the angle you have here. Also, this one will be theta. So these two angles at the center are always equal. In other words, if you find that the angle here is maybe, let me say 120, it means that this part up here will have a 60, and then the downer one will also be 60. Yeah, members, can you let me know whether we're on the same page? Are we on the same page? Are we good to continue? Okay. Okay. Yes. Okay. 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 So when those who are going to go into engineering, when you are drawing those diagrams, architecture drawings, they'll ask you design this kind of gear wheel, design this and this. You will be drawing these circles and then measuring. The first number is here, but this activity is for you to first try out. We are now going to apply. Can everyone first try out? And we see whether we can be able to get that X. Yes. Audrey, hope we're on the same page. Okay. Chemtai, hope we're on the same page. Elijah, Hannah, hope we are on the same page. Joyce, are you on the same page?
Yes, teacher.
Okay, is Emma attending?
Yes.
Okay, Emma, are we on the same page?
Teacher, he just went out, but he was here.
Okay,
Mm.
okay. Yes, Fiona. Yes, Fiona. Fiona.
Sir,
Yes.
can you hear me now?
Yes, you are clear.
I wanted us to try this number now.
Okay, it is okay.
Okay. Like we said, when a point from the tangency meets at the center, the angle formed is 90. So
Very
90
good.
plus the angle formed at the radius, which is 55, 90, okay, 55 plus x is equals to 90.
Really?
No, sir. 35,
80?
sir.
Okay.
Are you getting me?
Yes, which figure are we forming? What is the name of
It's a
figure OBC?
it's a right angle triangle.
Yes.
So 55 plus x will give us 90. Then if we take 55 the other side, we will have x as 35.
Sure. I've
Um,
not yet agreed with you. Let me hear what Amara is saying. Yes, Amara, what are you saying?
Yes, teacher, good morning.
Good morning.
So, as you are saying that as the radius hits the tangent, it forms an angle of 90 degrees.
Yes.
So, as now we can use another theory of, let me say, in angles, whereby that now a triangle adds up to 180 degrees. So you'll say 90 plus 55 plus x is equal to 180 degrees. Then the 90 plus the 55, you're going to get 145 plus x is equal to 180 degrees. So 145 minus 145 plus x is equal to 180 degrees minus 145 degrees. So x is equal to 35 degrees.
Okay. 35 degrees.
Degrees.
Okay.
Yes.
Okay. Thank you.
Welcome, teacher.
Okay. Okay. So Fiona, I don't know that Fiona. Yes, Fiona.
Yeah, I got the point now. I was kind of confused.
Oh, okay.
Thank
Okay.
you, Amara.
Okay. Desire?
There's also another, I don't know whether it's correct or not. When you
Mm.
just have
You just
when you do it, also get some answer. I
Yeah,
don't
you
know
get the
how.
same answer. But now we need to test it on different types of, let me say, different types of the property that you use. Because much as you get the same answer, you need to remember the angle properties. That which angle property are you using, such that you are specific.
Okay, sir.
Hmm. Okay. Yes, Steph Nasta.
Good morning, sir.
Yes, good morning.
Teacher, I was also inquiring about that even though I did not add the 90 to the 55, instead I
Hmm.
just equated mine straight away to the 90 degrees, I was still getting the 35 degrees.
Yes, it is okay. It is okay. Because you know it theoretically, it is very
Yes,
correct. What you are saying is okay. Because you already know that the angle here is 90. So 90 minus 55 will give you the angle that is remaining.
yes.
Yes. But now for me, or like what I want you to have in the mind is that don't use it anywhere, because the moment the angle is not 90, when it is not like a tangent, then you may
Yes.
still confuse it. That's where the problem may come from.
Okay.
But
Thank
that
you,
is
sir.
very correct. Yeah. Okay. Okay. We are here now. Can we first try it also? We are trying. There are two things. Okay, let me not give you anything. Can we first try? Yeah. Yes, Chris?
Good morning again.
Yes, good morning.
What I first did, I first bisected the angle at O.
Mm.
So I drew a straight line from O to bisect also X. Um, After that, I realized that I will get 70 degrees on each side.
Mm.
Then I also have my tangent, which is meeting my circle at the other end. If you could help me and name those ends, ABC.
Okay, I'll first continue. I'm listening.
Then after we have our tangent, we have 90 degrees
Mm.
for one triangle. 90 degrees plus 70 degrees is plus an unknown angle this side up. Let's name it R.
Mm.
Will be equal to 180. So we add 90
Mm.
plus 70 degrees
Mm.
plus R is equal to 180 degrees.
Mm.
160 plus R is equal to 180 degrees.
Mm.
Then R is equal to 180 degrees minus 160 degrees.
Okay.
then there our R will be 20 degrees.
Okay.
So we have two R's. We
Mm.
add R times R plus R, we shall get 2R. So 2 times 20, we shall get 40 degrees. So X is equal to 40 degrees.
Okay. Thank you. That is one approach. Okay. Yes, thank you, Chris. That is pretty okay. Yes, Magesi?
It's okay. I was going to work on the previous one.
Oh, no, like, is it the same approach you have used? Yes, Abe?
Teacher, for me, I had another approach. Yes,
Okay.
I first bisected it the way it is like this. Then, of course, yes, this if this is 140, after bisecting it, this side will be 70. Then also this side 70. So what I just did, since it's like that, then I decided to get X and added the 140, then subtracted it. I subtracted 180 minus 140, and then I got the 40 degrees.
Okay. 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 Desire. Thank you. Nasta.
The way I also did is like similar to us, though me, since this bisected one, I didn't bisect it, but since this right angle, this side is 90 degrees, and this other one is also 90 degrees. So I added the two angles together, whereby I got 180.
Okay.
This is now, I got 180. Then I just said X plus 140 will give us 180. Whereby I subtracted 1
Okay.
minus.
Now, I think I'm getting what you are doing. Now, you are doing two things. Please, I feel Desire, you are bringing in some quadrilateral property. When you tell me X plus 140 is equal to 180. Is it what you are relating to?
Okay, what I was just asking whether it's correct or not, because instead of bisecting it, I just added, because the two triangles, like one was having 90 and the other 90. So I just added them together and it gave me 180. So to get X, I just subtracted the 180 minus 140, giving me the X.
Okay. Now, I think, allow me to come in now. Now, we know very well that here we have 90 and also here we have 90. Like yesterday, I think I shared that whenever you have a quadrilateral, we know that any four-sided figure, whenever you add those angles you have inside that figure, you must get 360. So since this is the figure of the four-sided figure, the second approach you can use, you know that this is 90 and this is 90. So meaning that to get to come up with your answer of X, you can say X plus 90 plus 140 plus 90 is equal to 360 degrees. And therefore you go on and say X plus, that is what, 320 is equal to 360 degrees. And therefore your X will be 360 minus 320, and X is equal to 40 degrees. So this is the second approach I was waiting for. But the one I don't want you to use is whereby you just say these two are opposite to each other. Let me add. That one is totally different. That one only works when all the lines are inside the circle, not outside. Okay, let me hope that one is okay. So please, that one, don't just say X plus 140 is equal to 180. No, it's not true. Okay, Emma, is it a question?
Yes, I wanted to ask like the other second approach. It is like of the pie chart. Like it is like of the pie chart, because the pie chart is the one that adds up like what 360. Is it of that there are many things in the circle? Because it is of the circle, meaning that when you are calculating, it is like you bisect the circle, then it is like the pie chart, although that you have drawn it in the triangular in a shape which is not a circular. Is it like that?
Now, what
Yeah.
you are trying to bring in,
Yes.
the idea you are trying to bring in, it is actually not a pie chart, but that property tells us that angles at a point add up to 360. That's
Yes.
what you want to relate to. So they are a bit different.
Yes.
Now here, there are two things you need to know. Is that angles at a point, whenever you have a point here, because it is a circle, a point, you rotate 360 degrees.
Yes.
So as long as you're at a point, those angles will add up at 300, they will add up to 360. But also
Yes.
whenever we have a quadrilateral, any sided figure, let me say a triangle, a square, what, and you add all the angles inside, you'll end up with 360 degrees, the interior angles.
Yes.
Okay. Fiona?
So mine is also a question. I want to inquire whether it can be done in this manner also. If you see at the tangency where A meets, that tangency A and B, they are 90 if you add them all together, which will make 180. Then what if you subtract 180 minus 140 will still give the same answer of x as 40. Can it also be done in that manner?
Like you have put here 90 and
Yes,
here
A
90.
is 90, yes. It will add up to 180 minus the angle at point 0, which is 140. If you subtract from 180, it will give 40. Can it also be
Yeah,
done to get the
it
value of
is very
x?
okay.
Okay.
Okay. Okay. Let's try that. As I get to Brian. Yes, Brian.
Morning, sir.
Morning.
Sir, I had not understood you on that on method 2 you had used.
Method 2. Now, method 2, let me,
Yes,
do you know a quadrilateral, a four-sided figure?
yes,
So when you add, let me start from a rectangle. What
yes.
is the total degrees we have inside a rectangle?
Mm, that is 90 times 4, which is sir,
Yes, which is?
which is 360.
Which is 360 degrees, not so? Now,
Yes,
when you have any four-sided figure, whenever you find that this figure is four-sided, whenever you
yes,
add those angles inside,
yes,
your answer you get should be 360.
yes,
So when you look at the figure we had, it was also a four-sided figure, and
yes,
you had three angles already. So you were remaining with one angle, meaning that when you add all the three angles and that unknown, you must be able to get 360.
yes.
Hmm.
I now get your point. Thank you, sir.
Okay. Yes, Desire?
Answer
Yes?
that question.
Okay.
To me, I first put the right angle, which is 90 degrees.
Okay.
Then after I put the other side x, angle x.
Why?
Because it is also an unknown. We don't know what it is.
You're reasoning.
Okay.
You must,
Because
Apple, can we first get the reason from Apple? Yes, Apple, what is the reason?
I got this reason because you show that these two lines are equal. So if they are equal, this angle x is equal to this angle here x.
Perfect. So Desire, that's what you had to say. Because when you look here and this line are equal, so we are forming an isosceles triangle whereby the base angles will also be equal.
okay.
Continue.
So I get plus x is equal to 90 degrees since the two sides are equal. Is equal to 9. Sir, I said x plus x is equal to 90 degrees.
Okay, which property are you using?
Okay, like this other side and this other side are equal. So they are all adding up to 90 degrees.
No, because what you are saying will lead us to the right answer, but you need to have a backup of the property you are applying.
So I'm lost on that.
Okay, let me first say. Yes, Patricia.
Yes, Patricia. All right. Good morning.
Morning.
Okay. After identifying that is an okay, like the sides are equal, then we know that the sum of the interior angles equals to 180. Interior angles of a triangle. So it will be x plus 90 degrees will sum up to 180 degrees. So 2x plus 90 degrees equals to 180. 2x minus 90, we subtract 90 from both sides. 2x will give us 90. And divide both sides by 2. Then x will be equal to 45.
Yeah. Okay, that is okay. Yeah. So Desire, your approach is okay, but my only worry is you may use the same knowledge when you meet other triangles where it might not work. Yes, so that's why I'm interested in you knowing where it comes from. That angle property, that angles within a triangle add up to 180 degrees. So that is the property that I want you, where you come from, for you to get that 90, that when you add the two x's, you'll have 90. It comes from there. Yeah. Though now for you wanted to start from a bit ahead, but that's where it comes from. So I don't want you to take it that every time I meet this is what I must get. But I want you always to be able to relate to which property works. Okay. I have another one here. Still here, you are finding the values of x. But like I told you earlier on, much as we are in circle properties, you are going to find yourself that you may need quite a number of ideas. You may find that now we need something. Even at one point, we shall bring in the trigonometry in these circle properties. Now, after doing everything concerning the circles, we have reminded ourselves about trigonometry. That's when we shall go on and start now on a sum of the word problems. Because to do one word problem, you need to know almost everything within the topic. Yeah. Okay. So what could be your value? How come the radius is equal to the outer line? Oh, yes. Now it is possible, depending on, like when you draw, someone is asking on the previous number, because here, was it radius? Yeah. If this, let me say, is 5, if your tangent, you can have a smaller tangent of 5. It is very okay. Yes. So this is the distance of the tangent, the length of the tangent. So if your tangent was short, that it was just 5, it is very okay. They can have the same length. Yeah, those two can be equal. But always you need to first read the question. You need to read the question. But please do not forget that these diagrams are not on scale. They are not on scale. Yeah. I don't know whether the person who has... Oh, yeah. Okay, okay, Melissa. Okay. We are trying this. You are finding X. Okay, people are getting 13. Very good. Very good. Yeah. Those who are not getting 13, those who are not getting 13, please check out. That is a right-angled triangle. So I expect you to know how to use Pythagoras theorem. So we are using Pythagoras theorem. So that's where you must come from. Yeah. Let me hope everyone at least you know how to use Pythagoras theorem to get X. So when you get 13, that one I don't want to do it. Yeah. Yeah, but it is Pythagoras theorem. Please use it. 5 squared, 12 squared is equal to X squared. Okay. Okay. Yeah, you're going to allow me